We are at the beginning of electrification. There are a lot of players and only the most competitive will grow. We need to be at the same time very structured, to be quick to market, and to leave our employee be creative. So the way we work is that we have divided our development process into 4 steps. The pre-development, then the platform development, then the customer application, and then the serial life. Thanks to this pre-development and platform, we develop standard products which are answering the customer needs. We are able to be very quick to market based on this platform and to adapt it to the customer. Once it's in production, we improve quality, we reduce costs further along the serial life while we are preparing the next generation. We have the Siemens equipment to measure the noise of our motor, inverter, and reducer, and then we calibrate our model, and then we can target the best trade-off between noise performance and cost. Our engineers have benchmarked all the tools on the market, and it appears quite quickly that the Siemens tool was the best. The Siemens tool was the only one who was accurate enough to identify what was the root cause of some interaction.
In our process, what is very important is to identify if you have any structural resonances of the product which match with the magnetic force harmonics. To do so, we need to perform some model analysis with Simcenter Test Lab. For me, Simcenter testing solution is very interesting. First of all, the software is very friendly and explained in an easy way, step by steps, what we have to follow as main task from the channel setup to the measurement analysis. It is a very logical and very simple interface. We save a lot of time during preparations. Our core challenges is to test all the levels which need to be implemented to improve the NVH behavior of our product. And so we work closely with the simulation team. And then once we get solution which match for NVH and drive control, we are put in the loop to test if it worked in experimental condition.
I work on modeling and simulating the motor and e-powertrain systems that guarantee the low acoustic noise. By working closely with the technical teams, such as the electromagnetic engineers, the design team, and also with the test team, as I can provide them with the initial simulations to optimize their test mesh, and then they provide me with these results so I can optimize my model to be the most predictive for our systems. It is important to have the most predictive models from the early stages of the project because we have to strike a balance between different noise sources, such as the electromagnetic noise, but also the structure behavior.
Another activity very important is to correlate the feeling of the driver in the car with the measurement in this semi-anechoic chamber. A human being is not rational like a measurement of harmonics we can do in a room. So the Siemens tool was the only one with which we could correlate the feeling of the driver and the measurement we have here. And you know, as engineer, we can only improve what we measure. So if you want to improve the feeling of a driver, you have to make the correlation between the feeling of the driver and some harmonics we can measure, and this is what we have succeeded to do with the Siemens tool.